if you are writing junior Waec, or you have a sister, or you are a mother, this video is for you. Now, Bece or junior Waec asked us to provide this particular specimen for you. These are the specimens. We are asked to prepare measuring cylinder, then water, then spring balance. Now, then for the first part, we have another part: torchlight, bulb, and connecting wire, then battery. Now you can see apparatus for basic science practical. So this is for the basic science. Along the line, we can still provide another video for you. That could be maybe basic tech. Now, let me now introduce this measuring cylinder. This is what we call measuring cylinder. As you can see, we can use it to measure the volume of what's needed to experiment on. Now, this is the water. We are asked to provide water. This is the water, and we are asked to provide the spring balance. This is the spring balance, as you can see. Now, what is the function of spring balance? The spring balance is to measure the mass. That is the spring balance. As you can see here, you can see from 0 to what? To 500. So it has gram, which is measuring mass, and it has Newton, which is measuring weight. Meaning that this spring balance can measure two things: mass and weight. So now, this is what I can do. So let's start the experiment. Are you ready at home to start the experiment? So let's go. Welcome back. So this is the apparatus that I've already explained. I've explained this, the function, and this one. Now, what is included is the beaker. Beaker is not surface here, but from the question, they made mention of beaker. This is what we call beaker. Now, let me now tell you how the beaker is needed. Now, look at the question. You have to measure 20 centimeter cube of water. So this is what we can use to measure. Then you record, you measure and record. Now, then you have to determine the volume of what? The mass of the water. Now, put it down now. We have to measure 20 centimeter. Now, look at this. We have 20, 40, 60, 80, 100, 120, 140, 160, 180, 200, and 220, 240, 250. Now, we need to measure it from this to 20, this line. This is where our 20 ends. This is our 20. This is where it ends. Then we now move from this one to 40. So we have to stop our measurement here. So now there is a little water here. We pour it away. So now, we are stopping here. So another one from here will be 40. So now we take this beaker. This beaker. That is the same thing you do in your exam. Or it can also be applicable in, you can see more than, you pour it back until you get 20. So you see I have little to pour. I think small. You take small out of it. So we still need to take small out of it until we reach 20. I think it is there. Now, the next question says that then measure and record, meaning that the volume, we measure the volume. The volume of water used is equal to 20 centimeter cube. Then mass of water, which is, let's call this one V. Then let's call this one M. Now, then we are asked to pour it. We have to pour it inside the nylon. This is the nylon. You pour inside the nylon in order to get the mass. Now, let's see the mass. Let's calculate the mass. Now, as you can see here, look at from here, this is increasing by, I think, 20. So now, meaning the mass is 10, as you can see. The mass is 10 grams. The mass is 10 grams. So now, okay, it's 10 grams. 10. Now, from here, if the mass is 10 grams, the next question is, what is density? What is density? Now, when we say density, density is mass per unit volume. The density of a substance, density of any substance is what? Is mass per unit volume. That is the density of substance, mass per unit volume. Now, in this case, we can say it rho, which is the symbol is equal to m over v. Now, the question says what is? It may be calculated. If you are asked to calculate it, we can now say rho, which is the density, mass, which is equal to 10 grams, then all over 20. So we have this one cancelled, we have 0.5 gram per centimeter cube. That will be the density of this water. Now, the last question say two application of density. Now, number one, application of density is used in marine engineering. Why? For a body to float on a liquid or any fluid, the density of that must be what? The density of that fluid must be higher than the density of what? Of the particular body. So a marine engineer, they used to calculate they made the ship or anybody want to place on the surface of water have the less density by making the structure of the what. That is why you see the structure of what? The structure of a ship in hollow in order to display more water, the shape of the ship. So definitely it's used in engineering. Then number two that I can say here, it's also used to verify whether a particular substance is pure. Like, let me tell you, the density of water is 1 gram per centimeter cube, while the mercury is 13.56 gram per centimeter cube. So any density, if you take a substance and take it the mass with the volume must give you that answer, showing that particular substance is pure. The third one can be material identification, because different material have different density, which I've mentioned of what? I've made mention of water. The density of water is 1, while the density of mercury is 13.56. Other materials density. So definitely they can use to what? For material identification, in the application of material identification. So that by the time you measure you measure the mass of that any substance you are in question, then you divide it by the volume of that substance. Any answer that the result, you know that this is for this. For instance, here if I perform the experiment and I divide it and my answer is 1, showing that I'm talking about water. That is identity. If I now find a mass of a substance, I divide it by the volume, I get 13.56. Definitely showing that particular substance is a mercury. So material identification. Number 4, separation techniques. Because let me tell you one thing. By the time you get to mix water and kerosene together, is that taken? Because the water has density which is higher than the kerosene. What do you think that it is going to happen? The kerosene will flow up while the water will stay. So you can gently decantation will occur. You can gently pour out kerosene away from water. Is that taken? So meaning that the kerosene, the water will display kerosene, 4 for you. And let me go back to this. This one can lead to experimental error, or maybe the water is not pure. For normal water to be pure, what I did here supposed to be what? 1 gram per centimeter cube. So any substance, just look at the volume. You calculate the volume of that substance, you divide it by the what? The mass of that. So we give you the what? We give you the. So now let me just conclude it now. So we have performed the experiment. This is the answer. There is nothing else. I've answered everything. Then for the next one, wait for it in my next video. Thank you.